So let's start at the beginning, which I hear is a very good place to start. So hopefully if you're taking this class, you have some idea of what R is and what R can do. But I would like to be very specific, and I'd like to start by kind of defining some of these terms and explaining to you how all these tools we're going to use in this class interact with each other. So let's start with the main feature, R, the language you are here to learn about. So as you know, R is a programming language, and the important thing about R is that it was initially designed for statistical analysis. So basically, people said, look, computers are very powerful, they can help us do statistics, but we don't really have a language that lends itself well to those specific needs. So even today, as we think about R and its strengths and its weaknesses, we really want to think about them in this context, that it was designed for statistics. It was created by Ross Ihaka and Robert Gentleman back in the 90s, I guess before all of you were born, most likely. And this is actually why it's called R. A lot of people think that this is a joke about a preceding language, also for statistics, called S, or S+. And I think maybe that joke was deliberate, but really they called it R because it's their two first names. And so it was formally released to the world in 1997 by a group called the R Core Group. And you can see at this link who those people are if you're interested. It's a group of about 20 people. It's changed a little bit over time, but actually stayed fairly consistent with the original group. And these are the only people who are able to change the base functionality of R. What that means is when you install R on your machine, which you're going to do very soon here, all the tools that come with it are written or created or at least approved by this R core group. And R is an incredibly popular language and it's growing. So here is a study from this year. So this is the 2020 TIOBE is the group that does this study. And we can see here that last year, in June 2019, R was the 22nd most popular programming language. But we can see that as of June 2020, it's the 9th. It's cracked the top 10. That is a huge increase. And it's up here with all the other languages that you probably hear about in programming classes: Python, Java, C, JavaScript. So it's definitely not obsolete. A lot of people wonder about the relationship between R and Python. I can talk more about that sometime if you're interested, but long story short, there's room in this world for both R and Python, and there's a role for both of them, and R is definitely still a huge, huge language among people that do data science. So the strengths of R, the things that people come back to it for. Well, initially, its main strength was handling data with different variable types. So you might have categorical data, something like a person's name or the state that they're from, that kind of thing. And then you also have this quantitative data, so it's numeric. You've got like their height or their GPA, that sort of thing. And so most programming languages aren't really built to handle these two types of data together. They can do one or they can do the other, but they can't mix and match. But of course in statistics we have these data sets all the time where we need them mix and matched, right? It's the same person who we're measuring states and height and name. And so the initial point of building R, I think one of the initial focuses, was basically to create a language that could handle different data types, different variables in one setting. Now the thing that it's still probably at the forefront for, and was back when it was first created, was for data visualizations. So at first it was maybe the only language that could create these common visualizations that you've seen, like a box plot or a histogram. Nowadays, almost any language can do these things, or any language that handles data. But R is still considered to be at the forefront. There's a lot more flexibility, there is a lot more, I would say, artisticness in the visualizations that you make in R. And finally, because most of the people in academia or in industry research are using R for their statistics, any new methods that are created tend to be written in R first. For example, me, as a professor, if I come up with something new, I'm going to implement that in R. That's my fluency language. And so if you have other languages, and they all are being built to do statistics, these methods will eventually appear in things like Python or SAS or SPSS. But for the most part, they appear in R first. And for very niche projects, for methods that only apply in a very small number of settings, sometimes you will only find those methods implemented in R. So these are the strengths, and they all harken back to that origin story of R being a statistical language. Now that does come with some weaknesses. So here are the main weaknesses. First of all, because R was built for data analysis, it wasn't really built for all those other tasks that programming does nowadays. So although you actually can make a website in R, if this is your main job and your main goal, you're probably not using R. You're probably using Python or Ruby alongside JavaScript, HTML, some of these other languages. There's also a trade-off with what I was saying about the different variable types. So if you have written a language that can handle those types together, what you're giving up there is the ability to do numerical computations very, very quickly. So for something like a very large array of numbers that you need to do big matrix computations on, MATLAB is going to be far more efficient. For something where you're storing a lot of information and you're trying to be very deliberate about how the memory in the computer is used, something like C or C++ is better. And lastly, R is a true programming language. We are really writing code, we are really writing scripts, we will write our own functions. This is different from some tools that you may have seen in prior statistics classes. So SPSS, Stata, Jump, and Minitab, those are the ones I see the most often. These are all point-and-click tools. You have an interface and you can click a button that says do a t-test or do a regression. And for people that are doing simple statistical analyses, this might be better. It might be easier to not have to learn all the quirks and all the syntax of a new programming language. It might be better to just jump straight to a tool that has these basic analyses implemented already. So if that's your goal, and if you're here today, I'm sure that it's not, then maybe R is not for you. But if your goal is to do more complex analyses, be more creative with your visualizations, that's where the power of R comes in. Now, having said all this about the weaknesses of R, most of those things I just mentioned actually can be done very well in R. So this is one of the things that's coolest about R as a language, is that it is growing. I just showed you how quickly it is growing, and the developers who write in R are also increasing in their creativity and what they can do. And so almost anything that you want to do in R, even the most outlandish things, you can probably find a package someone has written that lets you do that thing. So I would say that the heart and soul of R and of other open source languages, which we'll get to in a moment, is this idea of packages. So a package just means some extra code, an extra set of code really, that adds some new functionality to R when it gets installed. For example, you might write a package that is very good at making a certain type of visualization. It makes that task easier or quicker or even possible. Now there is a such thing as official R packages, and they are stored somewhere called the Comprehensive R Archive Network, or we just say CRAN. I'll admit that I had to look that up to see what that stood for. Packages on CRAN have gone through some extra checks. There's a little bit more strictness in how the package is set up and how that code is written. But those aren't the only packages out there, so most of what we'll use in this class will be on CRAN. But even in this class, we're going to encounter packages that are not on CRAN. So it is totally possible for someone to decide, hey, I'm going to develop some new functionality in R, I'm going to store it in the form of a package, and I'm going to share that with the world without going through CRAN. Now with the writing of packages, why this is so possible and so popular is that R is what's called an open source language. If I ask you anything on a test or a quiz in the future about the history of R, it's going to be about this. It's going to be about open sourceness, because this is a huge distinction. So R is open source. Python is also open source if you've used it. SAS and MATLAB are not. Neither is Minitab, neither is SPSS or Stata. All of those ones are owned by companies. And so the company develops the software or the language or the packages for the language, and then that company sells that software to you. So if you're sitting here and going, hey, I actually used those things in class and I didn't have to pay for it, well, you did. Your university paid for it. So these are all licensed softwares. You have to pay into a certain private company in order to get access to the functionality of that code. So what this means is that nobody can sell their R code. So there are private companies that profit off R. One of them is called RStudio. And we'll talk about them in a moment because they've created a tool that is the most common tool for interacting with R. It's called RStudio also, that tool. I realize that's confusing. And so you can make helpers like RStudio, and RStudio is not written in the language of R. It is written to help you use R. So there are ways to make money around the culture of R, but it's not by writing your own R code and selling it. The other thing that is possible is that you can keep your code private. So just because you can't sell your code doesn't mean you must share every single thing you write with every single person in the world. And in particular, most companies and most organizations will have internal R packages or internal R code that they're using and sharing that they do not release outside of that company. And so that's allowed. They just cannot sell that software. And so what this means is if we want new packages that are freely available to everybody, those are created by people like me and people like you will soon be. They really just are written as a labor of love by people who have thought of an idea and decided to contribute to R. So I think that's very exciting about open source. I think it's one of the reasons why this is such a cool language, that it's so free and it's so created by the community. And so this does come with, I think, a responsibility to be a good citizen in that community. So as you are stuck with me, at least in this virtual environment, as I am your professor right now, I'm not going to let you out of this class without thinking about how to be a good citizen. And what that means to me is this. First of all, it means being willing to share your code. Even if it's not the most beautiful code in the world, even if it doesn't work yet, you are helping other people by putting your code out there in the public. Now, I understand this is your first R class, most likely, and so you're probably not going to want to take your assignments or your practice from this class and throw it out there for the world to see, and that's okay. But as you leave the class, or even as you do things in this class that you're proud of, I hope that you'll think about making those public. A little ways through the class, we're going to learn about GitHub, which is the way that most people share code. The other thing you can do to be a good citizen is to be part of this creation process. And now if you're not ready to write a package or to write something world-changing on your own, there's still a lot of ways to contribute to other people's projects. Again, this flows through GitHub mostly, which we'll learn about later. But the idea is no amount of contribution is too small. If you find a typo in someone's documentation and you tell them about it, you're contributing, you're helping the community. If you're able to fix a very small bug that you stumbled on, or even maybe you can't fix it, but you're going to report that the software doesn't work, that's helping the community. So as we go on, I hope that you'll be thinking of ways to contribute to each other in the class, and then after the class, to the community as a whole. And eventually, in this class, we are going to create our own packages, to some extent. They're going to be somewhat baby packages, because this is a first class, but they really will be package structure. So you actually will leave this class with the ability to write a package, if you so desire. And that's, of course, another way to contribute, is to take your package and share it with the community. Lastly, and this is very important to me, data science is not apolitical. Data science is not separate from society. The things you do with your skills in R and your skills in data science have an impact. And I really, really want to encourage you to be thinking about that impact. When you leave this class or when you leave your degree, you are going to probably get a nice job. I hope so. And sometimes in this job, people will ask you to do things with your skills that might not be ethical, that might not be respectful, that might not be responsible. It is your job, as the person with the skills, to think about how you use them. It is your job to think, is this thing that I am creating right now, that I am using my abilities to put forth, is it making the world a better place? And so please keep this in mind, not just in this class and not just in R, but in everything you do, that if you are going to be part of a community of educated people, then you are responsible for using that knowledge for good. So having said all that, let's take a moment to pause from this video and let's go try out typing our own R code in a few tutorials.